We've got this fenced plot of land. It's got an area of 1,200 meters squared. Fences for the two smaller sides are 60 and 80 meters respectively, and the angle between them is theta. Show that theta is 150 degrees and work out the total length of fencing. Right, I'm just going to go up to the degrees and leave the rest for you, but let's have a look at how to work that out. So first things first, let's detail the diagram. So let's put our detail in here. The area is 1,200 square meters, and then the two shorter sides are 80 and 60. Let's make this one 80 meters and this one 60 meters. I can't see where the pen is going. It sort of disappears. Right. So area of a triangle is equal to half AB sine C, the angle, the included angle, the angle in between. And we know it's equal to 1,200. So what we can do is we can say, well, let's label the graph. I haven't put theta in there. Sorry, not the graph. Triangle. That's theta. Theta is going to be our angle C. So a small c over that side. We have this as A, and this is B. So 80 is small b, and 60 is small a. So let's sub into our equation for the area. Half of 60 times 80 is, times sine of theta is equal to 1,200. So we're dividing by 2 on this side, so we can multiply through by 2. So we got 60 times 80 times sine theta is equal to 2,400. We can divide by 60 times 80. So sine theta is equal to 2,400 divided by 60 times 80 is 4,800. We can cancel the zeros, 2 zeros, 2 zeros. So sine theta is equal to 24 over 48, which is a half. Okay. So when it gives us a half, if I put that in my calculator, it tells me that theta is equal to sine to the minus 1 of a half, which is equal to 30 degrees. Now we've done that for GCSE, but that's not the only solution. There are additional solutions. Now if we look at this diagram, it can't be 30 because the angle is obtuse. It's more than 180. So what we need to do is we need to sketch our sine curve. Now you have done this previously, and I apologize for sketching on here. It's all freehand. So sine curve, if you recall, looks something like this. And if we go negative as well, I can't see where the pen starts. There it is. Doing this on the laptop is not the most efficient. So that's our sine curve. All right, call that sine. Oops, not there. Sine theta. That's a maximum value of 1, minimum value of minus 1. And these are degrees running along the x-axis. So that's our x-axis there. We've got degrees. Here is 180. That's going to be 360. And we've got minus 180 here. Minus 360. Now when you get 0.5 as your answer, as we did in this one, or a half, that is about there. Which means wherever it cuts the curve is a solution. So we've got two solutions there. I mean, the sine curve is infinite, so it does carry on. We'll stop at 360 though. But also we get negative solutions for a half. What you have been used to in your GCSE days is just going to the first solution there, which is the one that's calculated for you on your calculator, and that's 30 degrees. However, it's also cut the curve here. So it's cut the curve there and there. So that's also a solution. And because the sine curve is symmetrical, it's 0 to 30 from there, So it's also going to be 30 degrees away from 180, so that's 150 degrees. So that's also a solution. It also cuts here, so that's 360 plus 30, that's 390 degrees. We also had negative solutions, so it's cut here, that's 180 plus, sorry, minus 180 minus 30, so minus 210. So there's a range of solutions you can have. Now, sensibly, for a triangle, the angles are going to be clearly greater than 0, or less than 180 degrees. So that means the only two solutions we could have are 30 and 150. And in this case, because it's obtuse, let's put 30 or 150 degrees. Obtuse, so 150 degrees is the answer. Okay, good. I'll let you work out the total length of fencing. For that, you can use your cosine rule, find C, and then add 60 and 80 to it. There we are, good. Someone's asked another question, I think. So I'll post this and get on to the next one.